Youth Biolab Jeunesse.
Hi, I'm Steve.
I'm Meghan.
And I'm Anjelica.
We're from the Youth Biolab at the Albrechtsen Research Centre at St. Boniface Hospital. We all know the job of the hospital is to treat patients. Here at the Research Centre, our job is to study disease. If we ever want to cure a disease, we have to understand it first.
When you think of scientists studying disease, you probably think first of things like cancer or more recently, COVID-19. We don't study either of those here. But there are research scientists over at the National Microbiology Lab who are studying infectious diseases like the flu or COVID-19 or Ebola, where they have special equipment that can protect them from the germs that they're working with. There are also groups of cancer scientists working over at Cancer Care Manitoba in Health Sciences Centre, and it's their job to study cancer. We like to keep scientists together so that they can work as a team to come up with cures or treatments for these diseases that we see.
At the Albrechtsen Research Centre, we have three big interests. On our fourth floor, we have the Division of Neurodegenerative Disorders. This is where we study diseases that affect the brain and nervous system, just like Alzheimer's disease and type 2 diabetes nerve damage. On our third floor, we have the Institute of Cardiovascular Sciences. This is where we study diseases that affect the heart and cardiovascular system. On our second floor, we have the Canadian Centre for Agri-Food Research in Health and Medicine, and this is where we study food. They research foods that are really good for us, some that might be bad for us, and some that might be so good that they act like medicine.
Our lab, the Youth Biolab, was created so that we can share some of the things that we do here in the Research Centre with you. And hopefully we can help you learn a little bit more about how medical science works and understand a little bit more of the science of your own health.
Hi everyone. Today we want to talk about diabetes and blood sugar. Chances are you probably know someone with diabetes. Maybe it's someone in your family, maybe it's someone in your class, or maybe it's you. Diabetes is a very common disease and hundreds of millions of people around the world have it. More simply, 1 out of every 11 people have diabetes. Because it affects so many people around the world, doctors and scientists are interested in understanding diabetes and helping people live long and healthy lives. You've probably heard that diabetes has something to do with sugar. So before we dive into how diabetes affects people, let's begin with sugar. Why do we need it, and what does it do for our bodies? There is some form of sugar in almost everything we eat and drink. That's helpful because our bodies use sugar for energy, but not all sugars are the same. When we're talking about sugar in food, there are really two major groups, simple sugars and complex sugars. Simple sugars are usually small. They usually taste nice and sweet, like when you think of the sugar in your pantry. Your body is able to break down simple sugars quickly because they are so small. Since they break down quickly, they get into your blood quickly and cause a quick rise in your blood sugar. Our cells are very picky, and the only kind of sugar they use is called glucose. Glucose is one of the smallest sugar structures. Glucose molecules are like really small balls of energy for your cells. Your cells need glucose to grow and do all their special jobs. Complex sugars are much larger in structure. They are these really long chains of glucose linked together. Sometimes we call them complex carbohydrates or starches. Complex sugars are in all sorts of whole grains like brown rice, quinoa, barley, and even more foods. They're also high in beans and lentils and some fruits and vegetables. But they don't give foods a sweet flavor like simple sugars do. Have you ever eaten plain oatmeal? Oatmeal doesn't really taste sweet, but it's packed full of complex sugars. It takes your body a longer time to break the complex sugars down because they're so big. Because they take so long to break down, the complex sugars get into your blood slowly over time and don't cause a quick increase in blood sugar like simple sugars do. So you may be thinking, well, if our cells only use glucose, which is a simple sugar, why bother eating oatmeal to get the complex sugars that our cells can't even use? Well, there are these special enzymes in our bodies that cut long complex sugars into individual glucose molecules. That's what our cells use. So during digestion, the special sugar cutting enzymes come along and snip off of glucose, which then goes into our blood. And then they go snip and snip off another glucose and another until the chain is all broken up. It's a very tiresome job. When you eat simple sugars like table sugar, they're very small sugars made up of just 2 glucose molecules, and they're super quick and easy for your sugar cutting enzyme to cut. Cells need glucose to live and do their jobs, but there's a little problem. Even once the simple sugars make it into your bloodstream, your cells don't have eyes to see if there's any sugar in the blood, and your cells don't have tongues either to taste if there's sugar in your blood. So how do cells know when sugar is around for them to absorb and use? After you eat and start to digest your food, your blood sugar levels start to rise. The increase in blood sugar causes an organ in your body called the pancreas to make and release a hormone called insulin. Insulin has a super special job. It tells the cells, hey, it's sugar time. There's glucose in the blood for you to use. We do not want too much sugar hanging around in our blood, but we also don't want too little. Insulin makes sure the excess sugar gets used up by the cells by telling them it's sugar time. And when your blood is running low on sugar, insulin disappears and the cells stop using up all the sugar in your blood. You've probably felt insulin doing its job once or twice in your life. Have you ever gone trick-or-treating for Halloween and eaten most of your candy all at once? When you ate all that candy, did you feel super energized with a sugar rush, but afterwards you ended up feeling a little sick and tired, but still craving more sugar? When you eat foods with sugar, it gives you energy because now you have glucose for your cells to use. But if you eat too much sugar at once, your pancreas can overreact and release so much insulin that it tells too many cells that it's sugar time, and then you're left with too little sugar in your blood. Low blood sugar levels cause you to feel super tired and makes your brain tell your body, we're running low on sugar, we need more sugar. You might have heard of this before as a sugar crash. It's always best to eat candy and other sweets in moderation, and try to get your sugar fix from eating fruits with some complex sugars and lots of vitamins and nutrients, instead of the candies or sweets that are mostly sugar and don't have many nutrients. It seems really tough, but our bodies need a happy sugar medium. If we have too much sugar in our blood, it damages our blood vessels. And if we have too little sugar in our blood, our cells are starved for energy. So how are we supposed to know if we have the right amount of sugar in our blood? When your blood sugar is normal, then you probably feel normal. If your blood sugar is too high or too low, then you can start to feel a little different. When your blood sugar is high, you might feel very thirsty, have blurred vision, be super tired, and have to pee often. When your blood sugar is low, you might feel hungry, confused, shaky, and maybe even feel anxious. The way our bodies feel is a really good indicator of our blood sugar levels, but we can also find out exactly what our blood sugar levels are with this machine called a glucometer. The glucometer is able to measure the amount of glucose that is circulating in your blood. All this machine needs is a little drop of blood from your finger. When we're not eating, our blood sugar sits at a normal and steady level. If your blood sugar is low than your normal level, you need to eat. And if it's higher than your normal level, that's when you need some insulin. My normal blood sugar level when I'm not eating anything is around 5 millimole per liter. That may not mean much to you, and that's okay. This doesn't actually mean much to most people. So I would like to show you what this looks like. Based on my size, I have about 5 liters of blood in my body. This seems pretty shocking already, but what if I told you that in these 5 liters of blood, I only have about 1 1/4 sugar cubes. This is about 4.5 grams of sugar. I was pretty surprised. So how much sugar do you think I'm dumping into my body if I'm drinking this bottle of Mountain Dew? I'm dumping in 77 grams of sugar. So we're going from this to this. Do you think my body actually needs this much sugar? Someone my size only needs about 25 grams of added sugar per day. All of this sugar won't stay in my blood for long, probably a few hours. My cells will use up this extra sugar for energy, and what my cells don't use gets stored in my body as fat, and some gets stored in my liver as glycogen. Eventually, my blood sugar levels will go back down to normal. Insulin is a super important hormone, but sometimes our pancreas doesn't make enough insulin, or when we do make insulin, our cells aren't able to understand insulin's message properly. When these things happen, we have a disease called diabetes. When you have diabetes, it becomes very important to track the levels of sugar that are in your blood because insulin can't do its job properly. There are two types of diabetes. Type 1 diabetes is where your body makes little to no insulin. If the cells don't get the insulin signal, the sugars stay in the blood and the cells don't get any energy. Since people with type 1 diabetes can't make insulin, they have to inject it into their bodies so their cells know when sugar is around them for them to use. So if your cells aren't using up the sugar, where does it go? They pee it out. Out of every 10 people with diabetes, only one person has type 1. People are often diagnosed with type 1 diabetes when they're just children. With type 2 diabetes, your body still makes insulin, but your cells aren't able to understand its message properly. Over time, your body begins to produce less and less insulin because your cells don't understand the message. So why bother? Type 2 diabetes is often preventable, meaning that if you eat a balanced diet, exercise often, don't smoke, and get a good night's sleep, you drastically cut your chances of developing diabetes as an adult. People with type 2 diabetes don't usually have to inject insulin. They can manage their diabetes with diet, exercise, and sometimes a medicine that helps slow sugar absorption and helps cells use sugar properly. Out of every 10 people with diabetes, 9 of them have type 2. It's a super common disease, even though it's mostly preventable. People usually get diagnosed with type 2 diabetes when they're adults, but now it's even appearing in children as young as 10 years old. Right now, there's no cure for diabetes, but there is treatment. People are able to live long and healthy lives if they can manage their diabetes with exercise, diet, and proper use of medication. At our research center, we are very interested in diabetes. Our neuroscientists here are interested in how we can stop our nerves from dying when we have high sugar in our blood. Our heart scientists are interested in how high blood sugar affects how your blood flows and how it affects your heart. And our food scientists are interested in the foods that contribute to type 2 diabetes and what we can do to prevent people from getting diabetes. Every single time I eat, my blood sugar rises and my pancreas releases the right amount of insulin and my cells know when to use up the extra sugar. When people have type 1 diabetes, their pancreas doesn't release the right amount of insulin, and that's why they need to inject extra insulin. To know how much insulin to inject, people with type 1 diabetes have to monitor their blood sugar levels throughout the day. Today, we want to show you how to use a glucometer and test how simple and complex sugars affect our blood sugar levels over time. We brought in Slurpees to drink today. Each small cream soda Slurpee has 38 grams of carbohydrates. Slurpees are very sweet, so they're full of simple sugars. We're going to see how a drink high in simple sugars is going to affect our blood sugar. To see how the Slurpee affects our blood sugar, we are going to take an initial blood sugar reading to see what our blood sugars are normally before we eat or drink anything. This is called a control. We use controls to show how things are normally and how things change if you change something. So if I gave you a blood sugar reading that said 10 millimole per liter after I drank a Slurpee, that wouldn't really mean anything to you. But if I gave you a blood sugar reading of 4 millimole per liter before I drank the Slurpee and 10 millimole per liter after I drank the Slurpee, then you would know that my blood sugar changed by 6 millimole per liter. To take our blood sugar readings, the first thing we have to do is set up our instruments. Here we have a lancing device. This is what we're going to use to prick our fingers. To set this up, we're going to take off the cap, insert a lancet or a small needle, twist off the protective cap, and put our cover back on. And then to get it ready to use, we just press this button in the back. Next, we're going to set up our glucometer. All we have to do is just press the on button. Now that we're all ready and set up, I'm going to wash my hands and then check my blood sugar. Now that my hands are clean, I'm going to remove a test strip and insert it into our glucometer. Next, I'm going to prick my finger with the lancet using this button on the side to release the needle. And then I'm going to press out a little bit of blood and just touch it to the tip of my test strip. My blood sugar right now is 5.5 millimole per liter. In our lab, we like to do experiments as a group. Meghan, Steve, and I are going to measure our blood sugar every 20 minutes for the next 2 hours to see how Slurpees with lots of simple sugars affect our blood sugar. Today, we're going to see how different our blood sugar levels are going to be if we eat a snack high in complex carbs. A third cup of plain oatmeal has 20 grams of carbohydrates. We measured out enough oatmeal so our snack today has the exact same amount of carbs as our Slurpee did yesterday, which is 38 grams of carbs. Meghan, Steve, and I are going to test our initial blood sugar levels for our control, eat our oatmeal, and test our blood sugar every 20 minutes for 2 hours. The results are in. We used a line graph to show how our blood sugars changed over time from our Slurpees. This graph looks a little complicated right now, but this is Steve, Meghan, and my blood sugar changes over time from the Slurpees. We're all different, but our lines have a similar shape. They rise soon after our snack, but then they fall pretty soon after that. But what does this mean? This is a little hard to look at with all of these lines. So what scientists do is combine all of these results to get an average. So that just means combining our lines together to see what would happen to the average person. When we averaged it, we ended up with just one line. When we do a real study, like a clinical trial, we don't just take a few people and average their results. We use up to hundreds or thousands of people's results and average them to get a sense of what's going on in people's bodies. Here are our Slurpee results. Let's try and figure out together what this means. First, let's look at the title. It gives us an idea of what we're looking at here. So the title of this graph is Blood Sugar Change from Slurpee Over Time. This means we're seeing how Slurpees with simple sugars change our blood sugar over time. Next, let's look at our x-axis or horizontal line. We have time on our x-axis, and we chose to measure our time in minutes. This means when we see time point 0, this is where we started our experiment. And as we move to the right of the graph, we're moving farther in time. So here's 20 minutes after we started our experiment, and then 40 minutes after we started our experiment, etc. Next is the vertical y-axis, and we have blood sugar measured in millimole per liter, which is the value our glucometers gave us. If we're at the bottom of this axis, that means our blood sugar is lower, and if we're at the top of this axis, that means our blood sugar would be higher. A blood sugar level of 4 is much smaller than a blood sugar level of 9. Now that we know all the parts of the graph, let's try and read this. At time point 0, all of our blood sugar levels averaged out to be 5.4, which is normal for when you're not eating. But in our next 20-minute reading, after we drank the Slurpees, our blood sugars peaked to 7.9. This means the sugar we drank went into the blood really quickly, and our cells hadn't started up taking that sugar yet. Why weren't cells taking it up? Because there wasn't enough insulin letting cells know to take up that sugar. Our pancreas noticed a large amount of sugar coming into the blood in a really short amount of time. And it overreacted a little and released too much insulin, which told too many cells that it was sugar time. Eventually, our cells began to use up that excess sugar, so our blood sugar levels started to decrease. But it didn't just decrease back to normal. It actually dipped lower than our fasting blood sugar, which is a sign of a sugar crash. The pancreas was so overwhelmed with that huge load of sugar all at once and overreacted by making a little too much insulin, which told too many cells for too long of a time that it was sugar time. And this is why we experienced a sugar crash. When we add in our results from the oatmeal, the lines kind of have the same shape. Yes, our blood sugar levels from the oatmeal are lower overall, but we still saw a peak 20 minutes after we ate the oatmeal, which is not what we expected. We expected to see a nice and slow rise in blood sugar to about 6, maybe 6.5, and then a nice slow decrease back down to normal. In science, when you don't get the results you expect, you have to try and figure out why. So we figured out that quick oats, the oatmeal that we used, is a little more processed than we thought. Quick oats are steamed, flattened with a rolling pin, and then cut into smaller pieces. Since they're so flat and small, they cook a lot faster, and our bodies are able to break the food down quickly and absorb the nutrients inside. This is why our blood sugar reached its peak 20 minutes after eating. Our pancreas reacted to all of this sugar, but didn't overreact as much as when we drank the Slurpee. Our blood sugar levels are a little lower with the oatmeal than they are with the Slurpee. We decided to do one more blood sugar experiment using steel-cut oats, which is much less processed than quick oats, and we finally got the results we expected. We saw a nice and slow rise in blood sugar, and then a nice and steady decrease in blood sugar. This is because the sugar from the steel-cut oats get absorbed into our bodies slowly. The pancreas had time to release the right amount of insulin this time, so we didn't experience a sugar high or a sugar crash. My test subjects, Steve and Meghan, said that they began to feel tired and hungry near the end of our Slurpee and quick oats experiment because of that sugar crash. But with the steel-cut oats, they felt great and not hungry at all. It's really hard on our bodies if we're constantly having sugar highs and then sugar crashes and then sugar highs and sugar crashes all throughout the day. If you had a Slurpee for breakfast, you would get your sugar high right away, but then be super tired and hungry a few hours after. But if you ate steel-cut oats for breakfast, your body would absorb the sugar slower, and you would feel more normal throughout the day, and your belly would feel full for a longer amount of time. Even though we didn't get the results we thought we would with the quick oats and had to add steel-cut oats in at last minute, I would still call this blood sugar experiment a success. The Slurpee, quick oats, and steel-cut oats have the same amount of carbohydrates, but we were able to see that our bodies reacted differently to a Slurpee with added sugar, quick oats which have no added sugar but are processed, and the steel-cut oats that also have no added sugar but are barely processed. Every person is unique, and so are our blood sugar levels. Our blood sugar levels change throughout the day and rise at different rates after we eat and from what we eat. Meghan, Steve, and I are generally healthy, and none of us have diabetes, but we do have a lot of differences, like our heights, our ages, our weights, and even our eating habits, which all contribute to our uniqueness. Whether you have diabetes or not, it is super important to take care of yourself by exercising every day, eating a balanced diet, getting enough sleep at night, and listening to what your body is telling you. Even at your age, you can make the right decisions for your body that will benefit you when you're 70. Thanks for tuning into Healthy Curiosity. Stay curious. Make sure to click like and subscribe for more videos and follow us on Instagram and Twitter. To support the Youth Biolab's ongoing programming and expansion plans, please contact St. Boniface Hospital Foundation at stbhf.ca.